All right, number 5 here. I'm going to have to find the common denominator, and it looks like I'm just going to have to multiply each denominator or each fraction by the other denominator. So this one's got to be multiplied by x minus 1, top and bottom. This one's got to be multiplied by x minus 6, top and bottom. And I will get a common denominator of x minus 1 times x minus 6. I would just leave it factored, much easier that way. 9 times x minus 1 is 9x minus 9. X minus 5 times x minus 6 is going to be a trinomial. I'm going to get x times x, and I'm adding all of this, x squared. X times negative 6 and negative 5 times x adds up to negative 11x. I'm distributing each term, so I'm not writing it all out. Hopefully you understand what I'm doing here. Negative 5 times negative 6 is positive 30. So that's my numerator here. I just need to simplify it. A negative 9 and a 30 will combine, and this 9x and negative 11x will combine. So I'll have x squared, and 9x minus 11x is negative 2x. Negative 9 plus 30 is going to be positive 21, all over x minus 1 times x minus 6. Nice and pretty. Here we go with the next one here. I see that if I were to factor this, this would be 5 times x plus 2. Guess what? They already have part of the common denominator here, so I just need to multiply this one by 5, top and bottom. So my common denominator is going to be 5 times x plus 2. And then I'm going to have 10x minus, notice I'm minusing all of this, so it's going to be minus 4x plus 6, because that negative gets distributed to both terms. Very easily forgotten. 10x minus 4x is 6x plus 6. Common factor is 6. This is 5 times x plus 2. Even if I were to factor that 6 out, it won't make a difference because I can't simplify. So that should be my final answer. 6x plus 6 over 5 times x plus 2. All right, this is number 7. And these denominators look very, very similar here. So to get a common denominator, I don't think I need to multiply a lot. In fact, if you are used to these type of problems, you'll notice that this is just one of the denominators is the negative version of the other. So if, in other words, if I were to multiply this one times a negative 1, guess what it would be? Positive x minus 7. So I'm going to multiply the top and the bottom by negative 1, and I'll have the common denominator of x minus 7. 3 stays the same, and then instead of being plus 4, it's minus 4. So I end up with negative 1 over x minus 7, just like that. Beautiful. Moving along here. Oh, look at that. That is a beautiful trinomial that I'm pretty sure can be factored. One thing that I like about problems that are set up like this, they often give you one of the factors. I'm just going to go ahead and assume x plus 4 is probably a factor of this. So if x plus 4 is one of the factors, then the other factors must be 5, because 5x times x would be 5x squared. And the only way I could get 8 from 4 would be to multiply by 2. Everything's positive. Let's make sure that works. 5x times x is 5x squared, yes. 5x times 4 is 20x. 2 times x is 2x. And 20 plus 22 is 22. Yeah. And then 4 times 2 is 8, of course. So yeah, that definitely was one of the factors. I just guessed. But it's kind of safe to assume sometimes in these types of problems. But this one over here does not have the 5x plus 2, so we got to multiply it by 5x plus 2 to make it a common denominator. Top and bottom, of course. 5x plus 2. So I'm going to get that common denominator, so I can make it all one big fraction. And I'm going to be adding 10x plus 4. So that's going to give me a grand total of 10x plus 7 all over. You could put it in trinomial form or factored form. I like factored form better. 5x plus 2, x plus 4. Here we go. Oh my awesomeness, we have 3 rationals to combine. That is so great. I'm so excited. So we're going to start off with, of course, finding a common denominator. This is a difference of squares. They can be hard to recognize, but you got to pick up on that. Y minus 4, y plus 4. Y minus 4, y plus 4. Oops. Okay, this one already has a y plus 4, so this one's going to need to be multiplied by y minus 4. And we also have to get this y plus 7 in the common denominator too, because we want it all to be a single fraction. So we're going to have to multiply this one by y plus 7. We're also going to have to multiply this one by y plus 7. And then this one's going to have to be multiplied by both y plus 4 and y minus 4. Plus 4 and y minus 4. And of course, whatever I do to the denominator of a given fraction, I have to do it to the numerator. So if I multiply this first one by y plus 7, I'm going to have to do that to the top. So I'm going to get 4y times y is 4y squared. 4y times 7 is 28y. Oh, doggy, shush up, please. This is y plus 4 and y minus 4, which is basically the same thing as y squared minus 16. So I'm just going to do times y squared minus 16, which 2 times y squared minus 16 is, and this is being added, 2y squared minus 2 times 16 is 32. Finally, at the last part here, we're going to have minus, and we're going to have to put it all in parentheses because we're subtracting the whole thing up here. And it's basically y squared. 7 minus 4 is 3, so y squared plus 3y minus 8. It's helpful to know how to multiply binomials together. You basically just multiply the first and the last. That becomes the first and the last term. And then you add the numbers for the middle. But remember, when you distribute that negative, it's going to flip all of the signs. So that's going to be a negative y squared. So I've got 2y squared minus y squared. Oh, wait, no, there's a 4y squared. So I've got 4y squared plus 2y squared is 6y squared minus y squared is 5y squared. And then I've got 28y minus 3y, which would be 25y. Negative 32 plus 8 minus the negatives plus. Negative 32 plus 8 is going to be 24. Man, that was so close to all being divisible by 5. That's on the top. 5y squared. Let me just double check my work. 6y minus y squared. 28y minus 3y. And negative 32 plus 8. Ooh, there's a mistake. There is a mistake. This, wrong button, is going to be a minus 24 because it's negative 32 plus 8. So it's going to be negative. Then on the bottom, I'm going to list them all separately. Y plus 7, y minus 4. You could multiply them all together, but that's extra work I don't want to do, and I don't think you want to do either. There's our nice, simplified answer. So great. So great. Oh my gosh, why didn't you guys correct me? Why didn't you correct me? This is supposed to be a minus 28. Negative 4 times 7 is 28. Nobody said anything. That's messed up, guys. Anyways, this negative 32 plus 28 is not going to be negative 24. It's going to be negative 4. Made a mistake. Kissed a snake. How many doctors will it take? You can count. Anyways, it's fixed now. Everybody makes mistakes. Just fix your mistakes and learn from them. Okay, now on to the next one. This is a complex fraction. Basically, it's a fraction divided by a fraction, or rational divided by a rational. And hopefully you remember that if you're dividing by a fraction, you're really multiplying by the reciprocal. So we're going to take this bottom half, we're going to flip it upside down, and we're going to multiply the top by it. So this is going to be x minus 3 on top, and then 2x to the fourth on bottom. And then it's just a matter of reducing. Right here I can see that I've got this x to the fourth and x to the fifth, so that's going to clear out there. This is just going to become a 1x. And then this right here factors. I'm pretty sure x minus 3 is one of them. X plus 5 would be the other one. So x plus 5, x minus 3 is what that equals, and then the x minus 3's cancel out. So on top, all I have is an 8x. And then on bottom, all I've got is this x plus 5. This has been factored, and a 2. Oh, but I can reduce that even more. So x plus 5, and the 8 over 2 can reduce to 4 over 1. So I've got 4x over x plus 5. Hey, it's actually kind of clean this time. I like that. I like that. 4x over x plus 5. OMG, this looks so awesome. Love it. It's all about common denominators. Whenever you're adding and subtracting fractions, you need common denominators. So basically, we're just going to complete the subtraction on the denominator and complete the addition on the numerator. Then we'll have a complex fraction, and we'll multiply by the reciprocal of the denominator. Okay, so for the top, we're going to have a common denominator of 7x. This one gets multiplied by x. This one gets multiplied by 7. So this equals x plus 7 over 7x. Right? Let me just clean that up because I buried everything I was thinking about. Yeah, that one gets multiplied by x, that one gets multiplied by 7. If you didn't notice, a lot of times it's cross multiplying. Same thing here, cross multiplying. I'm going to have the big divider there, and then this one's going to be x squared. Multiply that by x squared. Multiply this one by 49, so minus 49 all over 49x squared. All right, now we've got a complex fraction. Guess what we're going to do? We're going to multiply by the reciprocal. So my main fraction on top here is x plus 7 over 7x, multiplying by 49x squared over, who sees a difference of squares there? That 49 should trigger your brain to think that is a perfect square. X squared obviously is squared, so it's perfect square. So this I can factor into x plus 7, that looks familiar, times x minus 7. Beautiful. Okay, we are going to divide x plus 7 by itself, that equals 1. We are going to divide 49 by 7, that's 7 over 1. And then we've got x squared divided by x, so that becomes just an x on top. So I've got 7x, 7x, 7 and an x, right? And then on bottom, that 7's gone, that x is gone, that x plus 7 is just x minus 7. Nice. At least we end up with a clean answer. The next one. Now we've got a simplified fraction on top. Good. But you can see this is not simplified. We're gonna have to do some common denominator action. W plus 4 over here, W minus 6 over here. We're multiplying on top and on bottom. So let me rewrite this. Why is it so hard for me to draw a straight line? There we go. 2 over W plus 4. And then the common denominator here is going to be W minus 6 times W plus 4. And then this one's getting multiplied by a w plus 4, so it's going to be 3w plus 12. This one's getting multiplied by w minus 6, so it's w minus 6. But we are subtracting everything, so this is going to be a minus w and a plus 6. Flips the signs when you're subtracting an entire numerator. 3w minus w is 2w. 12 plus 6 is 18. All right, now I've got a fraction divided by a fraction, so I multiply by the reciprocal. Awesome. Top fraction, 2 over w plus 4. I shouldn't be calling them fractions, but rational, whatever, who cares? I'm going to be multiplying by w plus 4 times w minus 6. I changed the order, it doesn't matter. And then 2w plus 18 is on the bottom. I'm going to go ahead and factor that with the GCF of 2, and that's going to be w plus 9. Let's make sure that works. 2w plus 18. Yeah, it's the same thing. All right, so I see here that I've got a lot of common factors. W plus 4, 2, and 2. So realistically, this is all I need for the answer, w minus 6 over w plus 9. Awesome. Ooh, some more fun. Yes. Just going to get it so that the numerator is all one fraction, the denominator is one fraction, and then, being a complex fraction, we're going to multiply by the reciprocal of the denominator. This one needs to be multiplied by x, this one needs to be multiplied by y, this one needs to be multiplied by x squared, this one needs to be multiplied by y squared. And I'm talking about top and bottom. I've done it enough times, I feel like I don't need to write it all out, hopefully. Casual Friday. Is it? Teacher texting. Okay, let's simplify this. This one is going to be 7x plus 7y over xy. Common denominator, xy. Multiply this whole thing by x, multiply this whole thing by y. Right, big divider. Now I'm going to have x squared over y squared, x squared minus y squared all over x squared y squared. So I multiplied all of this by x squared, and I got x squared over x squared y squared, and I got y squared over x squared y squared over here, so I can combine them into one fraction, x squared minus y squared over the common denominator of x squared y squared. That is not a tongue twister at all. Same processes all the time now. Hopefully you're catching on here. I'm going to write the numerator 7x plus 7y over xy. I'm going to multiply by the reciprocal of the denominator, x squared y squared over, now this is getting tricky here. I don't know if you guys see this, but let me leave it to you. Let me see if you can sense this. This is x squared minus y squared, all right? I know that x squared over x is going to reduce to just x. Y squared over y is going to reduce to just y. Is there anything going on here, though? Does anybody see that? You probably do. I see you seeing that. But let me spell it out for you clearly. This can be factored, because they both have a 7, to 7 times x plus y. This is a very, to me, obvious difference, subtraction, of two squares, perfect squares. So instead of writing it like that, I could write x plus y times x minus y. Same thing. So now, guess what? There's a common factor, x plus y. Yay. So the x plus y cancels out. This is all gone, by the way. And I just have a 7xy on top. So all of this equals 7xy. And then on the bottom, that's gone, that's gone, that's gone. All I have is an x minus y. I love it when it reduces to like something very simple. Some of my favorite problems are where you have this huge equation or expression and the answer is 1. So great. It's amazing. The final problem. The trick on this one is to focus on the parts that are associated first and then just kind of do it one chunk at a time. Don't worry about the top right now, we'll get to it. Don't worry about this right now, we'll get to it. What we're going to focus on here is this fraction, or rational, whatever you would call it. 5y over 3 plus 5 over y plus 1. Let me just write that. 5y over 3 plus 5 over y minus 1. I'm just going to address that. Notice the bar only covers up to here. It doesn't include this y. That's why I'm focusing so much on that. Because if we can simplify this, it's going to simplify everything else. First thing I want to do is look at this denominator here. I don't have a common denominator, so I need to multiply this by, this is basically over 1. So I have to multiply it by y minus 1 over y minus 1. And I get myself this 5y over 3 times y is 3y. 3 times negative 1 is negative 3 plus 5 all over y minus 1. And 3y minus 3 plus 5 can be simplified. I'm going to erase here because I don't want to run out of space. Negative 3 plus 5 is 2, or 5 minus 3 is 2. So that's the simplified version. And then I'm going to go ahead and multiply by the reciprocal, which this is over 1. So when I multiply by the reciprocal, I basically take this fraction and multiply it by, let's use red again, y minus 1 over 3y plus 2. And the 3y plus 2 still remains the denominator. So 5y times y is 5y squared. 5y times negative 1 is negative 5y. And then on the bottom, I'm still going to have that 3y plus 2. All right, that is this part simplified. So let's write the whole thing with this part simplified. I'll do that right here. Y over big, cute. No, that's not cool. Let's try again. One more time. There's something decent. Y plus, and I've got 5y squared minus 5y over 3y plus 2. Again, focus on this part first, and then now we're going to try and get a common denominator here. This is over 1, so we're going to have to multiply by 3y plus 2, 3y plus 2 to get a common denominator of 3y plus 2. So this is going to be y over 3y times y is 3y squared. 2 times y is 2y. And then we've got plus 5y squared minus 5y. And all of that is over 3y plus 2. It seems a lot more complicated than it is. You just got to take it one chunk at a time. Simple steps, but you got to follow the process. Trust the process. All right, so now this is y over 1. Any whole number or any integer or any term is being divided by 1 unless otherwise noted. But I'm going to multiply by the reciprocal. Before I do that, though, I can notice that 3y squared and 5y squared are the same, so that's going to be 8y squared. So let me rewrite everything here, even with the y over 1 over 8y squared, and then 2y minus 2y minus 5y is negative 3y. And then we've got the 3y plus 2. We're going to multiply by the reciprocal. I'm going to flip this upside down, so this is going to be times 3y plus 2 over 8y squared minus 3y. I just flipped this whole thing and put it there. So we don't need to worry about this. We're just looking at this part here. Let me write it here. Y times 3y plus 2 over, now I noticed that in this denominator part right here, I've got a common factor of y. Why is that important? Well, look, y over y. It'll simplify. And this would become 8y minus 3. Those cancel out, and this is my answer here, 3y plus 2 over 8y minus 3. So much fun. I really do kind of enjoy that. 3y plus 2 over 8y minus 3. Okay, so that's the end of this video. Just quickly going to show you kind of the progression of things here. This semester, we started off with logarithms, and we went through all of that. I never tested on it. So hopefully you remember logarithms, because it will be a portion of what you're responsible for, Algebra 2. Systems of equations and systems of inequalities, that's part of our project. That's Algebra 1. So yes, you need to know that too. I didn't test on that either. We've just got so much that we need to be able to do to keep up with what's expected of your age group. But what I am going to eventually test on is these rationals. And I like rational expressions because they incorporate factoring as well. So it adds a lot of diversity to the problem types. Eventually we're going to be testing on simplifying, adding, subtracting, multiplying, dividing, arithmetic, complex fractions, equations, we'll get to that, and then applying those equations, and that'll be what the test is on. So that's where we're headed. That's the idea. But the main idea of everything is that you guys are prepared for your future. You guys are on track to be successful in whatever you do. Okay, bye.